For today, I'm going to have you do these 4 problems on this handout, and then I'm going to have you do these 4 problems in your packet again, and then have you do these 4 problems for a third time in your composition notebook, writing a complete sentence for each. So that is your homework. Alright, so here we go. For these problems, I'm going to have you pick a point on either side of this line, plug in the point for x and y, see which has a true statement, and then which one is true. I'm going to have you shade into that zone. So here we go. For that first problem, I'm going to pick nice, easy points. Looking at that graph, that inequality is y less than. So I want you going into these problems knowing that less than is going to be shaded below, which means these points down here are going to be good. So I'm going to be using green for that. These points up here will be bad because that's red. That is not where it's going to be shaded. So going into this, I want you to kind of have an idea which side of the line you will be shading on. I'm going to pick 0, 0. I'm going to pick 0, negative 5. So 0, 0, the point 0, 0, plug in x and y is 0 into this inequality. Gives me 0 less than or equal to negative 0 minus 4, because 1/5 times 0 is 0. 0 less than or equal to negative 4 is not a true statement. 0 is not less than negative 4. You would rather owe someone no money than owe them $4. So again, 0 is not less than negative 4. When I plug in the other point, which is 0, negative 5, this one should work because again, going into this, I know it should be shaded down. So plug it in for x and y, negative 5 for y, plug in 0 for x, 1/5 times 0 is just 0. That gives me negative 5 less than or equal to 0 minus 4. Negative 5 is less than negative 4. That is true. So I will shade down below now. Every point in this shaded zone will give me the same result, will give me a true statement, and then points on this line, which we'll start looking at, will also give me a solution. Looking at number 2, this inequality is y is more than is always shading above. So going into this, I have an idea that the good points will be up here and the bad ones will be below. So I'm going to use red to represent the bad ones and green to represent the good. So when I plug in 0, 0, 0 for x, 0 for y, gives me 0 greater than or equal to negative 3 times 0 plus 5. 0 greater than or equal to 0 plus 5. 0 is not greater than 5. That is a false statement. When I plug in this green one in here, 2, 2, 2 for x, 2 for y, that gives me 2 greater than or equal to negative 3 times 2 plus 5. Gives me 2 greater than or equal to negative 6 plus 5. That is a true statement. 2 is greater than or equal to negative 1. That is true. Every point above that line will give me a true statement. So I'm going to shade above. When I do number 3, you got to be careful because it is not solve for y. Unless it's solve for y, I cannot really look at the inequality and know. I know this is going to be below, I know this is going to be above, but this one right here, it might be below, it might be above, I'm not sure. It is not solved for y. So this one, I'm going to do a blind check. I'm just going to plug a point above the line, point below it, and then see which one works. So 0, 0 is right here. That would be 5 times 0 minus 2 times 0 less than or equal to 10. 0 minus 0 less than or equal to 10. 0 is less than or equal to 10. That is a true statement. When I plug in the other point, which is 4 for x and 0 for y, 5 times 4 minus 2 times 0 less than or equal to 10. That gives me 20 less than or equal to 10. That is a false statement. 20 is not less than 10. I know all these points over here will give me false statements, which means the shaded zone will be above. If I were to solve this for y, And my last step would involve dividing by -2. That would flip my inequality to the more than direction. So yes, that is accurate. When I do number 4, looking at it, again, not solve for y, but because you're smart, you know you'll be dividing by +4, so you know your inequality is probably going to stay remaining more than, so above will probably be good. But here we go. Plug in 0, 0, plug in 0, 7. 0, 0 below the line gives me 3 times 0 plus 4 times 0 greater than or equal to 24. That is a false statement. 0 is not greater than 24. When I plug in 0 and 7, 3 times 0 plus 4 times 7 greater than or equal to 24. That is a true statement. 28 is larger or equal to 24. So yes, that is a true statement. You will shade that one above. All those points in there will be proper points. And again, I know that because I would not divide by -4 right here, so my inequality will not switch. It will be more than or equal to. All right, for these problems, I'm going to have you solve these for y if they need to be graphed. I'm going to have you graph them, and then I'm going to have you plug in 3 points, one above the line, one below, and then 1 point directly on the line. So for here, this is solve for y, so 4 is my y-intercept. From there, I'm going to go over 1, down 2, over 1, down 2, over 1, down 2. My run is 1, my rise is -2. Be able to stair step both directions. That will be a dotted line because my inequality is a plain incomplete inequality. Dotted line. Y is less than will be shaded below. So that will be a dotted line shaded below. And then what I'm going to have you do is plug in 3 points. I'm going to have you plug in a point below that dotted line, a point on that dotted line, and a point above. I know the shaded zone is going to be below, so now I'm going to check my work. So I'm going to pick a point in the shaded zone. 0, 0 is nice and easy. I'm going to pick a point on the line. 0, 4 is going to be a nice easy one. And then a point above. So that's going to be 3, 3 right there. And I'm going to show you that the point in the green will work. The point on the dotted line will not. And then this one in the non-shaded zone will not as well. So here we go. So 0, 0, 0, 4, and then 3, 3. Only one of these points will work. Only this one in the shaded zone. So 0 less than, I'm sorry, that should be just plain old less than. -2 times 0 plus 4 is 0 less than 4. That is a true statement. So again, don't write that equal liner there. I'm not sure why I wrote that. That is true. So when I plug this in to the other one, 0 less than or equal to -2x, 2 times 0 plus 4. And now I'm going to erase that because I plugged in the numbers in the wrong place. And I'm not sure why I'm putting that equal line under there. Don't do that. Don't do magic like I'm doing there. So that will give me 4 for y. There we go. Less than -2 times 0 plus 4. And it looks like I fixed that up. So now I have my right proper inequality. Plugged in 4 for y, 0 for x. That should give me a false statement. That gives me 4 less than 4. That is not true. If this was less than or equal to and my line was solid, then that would have given me a true statement. So again, here we go. Now plugging in my other point, 3, 3. That should definitely give me a false statement. 3 less than -2 times 3 plus 4. 3 less than -6 plus 4. That is a false statement. 3 is not less than. Let me check that one here. So again, I plugged in 3 for x, 3 for y, negative 6. This gives me 3 less. That is a false statement, so that is true. So here we go. Next one. That is solved for y. So right away I start at negative 3 on the y-axis. My run is 3, my rise is 1, over 3 up 1, be able to graph. Be able to stair step the opposite direction. This will be a solid line because of my inequality. It is more than or equal to, so I know it will be shaded above. I'm going to pick a point in the shaded zone, a point on the line, and a point in the non-shaded zone. Trying to pick nice, easy points. So 0, 0 is in the shaded zone. That one should work. The point on the line for this one will work as well because this is more than or equal to. And then the point below will definitely give me a false statement. That 0, negative 5, 1 will not work. So 0, 0. When I plug in 0 for x and 0 for y, it gives me 0 greater than or equal to 0 minus 3, because again, 0 times 1/3 is 0. That is a true statement. 0 is larger than negative 3. You would rather owe someone $0 than $3. When I plug in 0, negative 3, 0, and again, I'm going to fix that because again, I should be plugging in negative 3 for y. And I believe I will fix this. Again, make sure when you're plugging in your points, 0 for x in this one, negative 3 for y. So here we go. I'm going to fix that. So I'm going to plug in negative 3 for y, greater than or equal to 1/3 times 0 minus 3. Gives me negative 3 greater than or equal to negative 3. That is a true statement because of that equal line under there. So that's why you draw a solid line, because all those points, because of that equal line, will give you a true statement. And then when I plug in 0, negative 5, negative 5 for y, greater than or equal to 1/3 times 0 minus 3. That will give me negative 5 greater than or equal to negative 3. That is a false statement. All right, next two. I'm going to write those as inequalities. I'm not sure why I wrote those as equations, so I will fix those and write those as inequalities. I'm going to move that around a little bit. So when I'm solving this, I'm going to solve this inequality for y by getting rid of the 2x first. I am going to make these inequalities. I'm not sure why in the original video I wrote those as equations. So there we go. So when I solve that inequality for y, I take away 2x on both sides. Do not combine negative 2x and 6. Write it in slope-intercept form with a negative 2x first. Divide everything by 3. So that 3 divides into that negative 2. That 3 divides into that 6. So when it's simplified, y less than or equal to, do not flip that inequality. You're not dividing by a negative number right there. It gives me y less than or equal to negative 2/3 x. And then I get this 2 by dividing 6 and 3. So that equation or inequality starts at 2. Every time I run 3, I go down 2 for my rise. So run of 3, down 2. Run of 3, down 2. Be able to stair step both ways. That is a solid line because of that inequality. It is less than, so I will shade below. I'm going to pick 3 points for you to plug in. I'm going to pick a point on the line, in the shaded zone, and then a point above. So 0, 0. That one should work. That is in the shaded zone. So 0 less than or equal to. And again, I'm going to plug in 0, 0 into this original equation right here. I could plug into each one I want, but this one to me looks a little bit easier. So 2 times 0 plus 3 times 0 less than 6 is 0 less than or equal to 6. That is true. So now I'm going to plug in 0, 2 on that line into this original inequality. Again, I could plug into either one because these are equivalent. 2 times 0 plus 3 times 2. 6 is not less than 6, but because they have that equal line under there, that makes that true. 6 is equal to 6. And then 0, 4 should not work. 2 times 0 plus 3 times 4. 12 is not less than 6. That is false. All those points up there will give me a false statement. Only points in the shaded zone or on this line. If it's dotted, points on the dotted line do not work. And this last one, solving this for y, I'm going to add 3x to both sides because the opposite of subtracting 3x is adding. That will give me 4y greater than or equal to 3x plus 8. Divide everything by 4. That gives me y greater than or equal to 3/4 x. And then 8 divided by 4 is 2. So that means my y-intercept of 2, every time I run 4, I go up 3. So start at 2, go to your right 4, go up 3, to your right 4, up 3. Be able to stair step the opposite direction, left 4, down 3, which is still a slope of 3/4. That will be a solid line because of that inequality. That is shaded above. That is more than. So now to prove that, I'm going to pick a point in the shaded zone, a point on the line, and a point not in the shaded zone. So the point in the shaded zone looks like 0, 4. That one will work. I'm going to plug in 0, 4 into my original inequality right here. So negative 3 times 0 plus 4 times 0. It looks like I'm checking 0, 0 first. I'm sorry. So that gives me 0 greater than or equal to 8. That is a false statement. This point 0, 0 for x and y did not work. Now I'm going to plug in this point right on the line, which should work because it's a solid line. So 0, 2. Negative 3 times 0, 0 where x is, plus 4 times 2, 2 where y used to be. That gives me 8 greater than or equal to 8. That is a true statement because of that equal line under there. So yes, that is true. And then when I plug in 0, 4, that one should work for sure. So 0 for x, plus 4, 4 for y. And that gives me 16 greater than or equal to 8, and that is a true statement. Now what I'm going to do, I'm going to show you how to use the software Desmos to plug in these inequalities for you to start looking at these graphs. We're going to start to use this program a little bit more. So here we go. To show you Desmos, I am going to go to the internet. I'm going to go to Google. When I go to Google, I'm going to type in Desmos, D-E-S-M-O-S. Super easy to spell, Desmos. It is free graphing program. So Desmos, beautiful free math. Click on that. Click on Start Graphing. And then what this does, it gives you the ability to type in your inequality right here, and then it will graph it for you. So I'm going to do this first one right here, y less than negative 2x plus 4, and see if it matches this graph right here. So y less than negative 2x plus 4 should give me this graph line, dotted line, should look like this. Let me see. So to get my keyboard, I click down here, and I will get that going. So there it is. So you type it in exactly. You got your x, y, you got your inequalities, you got your numbers, you got your plus. So y less than, type it in exactly. Y less than negative 2x plus 4. And then you could get rid of that keyboard. You could zoom out if you want to see your graph. And if you see, this has a y-intercept of 4. It has an x-intercept of 2. It has a dotted line that should match my graph if I did that graph correctly. So y-intercept of 4. Yep, right there. Y-intercept of 4, x-intercept of 2, dotted line. So even though that graph looked a little bit neater, it is the same graph as mine right here. So I'm a happy guy. Now I'm going to do this one. And again, for this, I could either plug in this inequality, and then I'm going to show you this one to show you that they give you the same graph because they are equivalent. So here we go. I'm going to X this out, and now get my keyboard back and type it in exactly. So 2x plus 3y less than or equal to, right here, 6. And then there's my graph. If I zoom out, might not help me. So I'm going to zoom back in, I believe. There we go. So again, a y-intercept of 2, 0, 2, an x-intercept of 3, 3, 0, solid line. That should match my graph. And let's see if it does. And yes, it does. There's a y-intercept of 2, an x-intercept of 3, 0, 2, 3, 0, solid line, shade below. So that does match my graph. I know I did that correctly. Now I'm going to plug in this one to show you that you could plug in the same equivalent inequality and get the same graph. So I'm going to clear that out. These are a little trickier, but you could type these in too. So y less than or equal to, for the fraction, you hit the top number. Oh, got to make that negative. And then hit division. And then don't hit x down here. I got to erase that. And you want a space before you hit that x. So that's negative 2/3 times x. And then we'll get our y-intercept over there plus 2. And then there's the same exact graph. Y-intercept of 0, 2, x-intercept of 3, 0, solid line shaded below. All these points will satisfy this inequality. All the points on the line, none of these will satisfy the inequality. All right. Good luck. So for your homework, make sure you finish those 4 problems. Make sure you do those same 4 problems in your packet. And then make sure you do those same 4 problems again for a 3rd time in your composition notebook, writing a complete sentence for each one. Good luck.